In this video, we are going to take a look at doing some substitution with functions, and this exercise will kind of get us used to some function notation, because what we're used to seeing, probably up to this point, is we're used to seeing y equals. Well, we're not going to be doing y equals, we're going to do f of x, which is saying the function of x, because this is the function with the variable x in it, and if I plug in the domain variables for x, I will get equal one value for my y. So again, plugging in a single value of x will give me a single value of y, because this is definitely a function. Okay, so let's do a through h for this problem to finish this video. So we're going to start off with part A, which is the function at 0. So what I'm going to do is I'm going to plug 0 in for each instance of x. So I have -2. I will use parentheses for each instance of substitution. That way I get to see how the exponents work and can perform order of operations correctly. Because we would take care of what's inside the parentheses first, then the exponents. So this would be -2 times 0 squared. So this is -2 times 0 plus 0 minus 1. Now we do multiplication and division next, so -2 times 0 is 0 plus 0 minus 1. So f of 0 is equal to -1. Now we're going to go to part B. We're going to do f of 1. So we're going to plug in that 1 into each value of x using parentheses for my substitution. That way it can take care of negatives and exponents correctly. So this is -2 times 1 plus 1 minus 1. -2 times 1, doing order of operations, is -2, and the plus 1 minus 1 makes 0. So -2 plus 0 is our answer. So f of 1 is equal to -2. So the next thing I'm going to do is part C. I'm going to use my -1 here. So again, plugging in my -1 with parentheses, and this is going to make a big difference here since that square of the -1 is going to make 1. -1 times itself is 1. So here I have -2 times 1 minus 1 minus 1. And so -2 times 1 is -2 minus 1 minus 1. That answer is -4. So my f of -1 is equal to -4. Okay, so for part D, I'm going to plug in -2 for every value of x. And this is also important because we want to do all parts of the algebra correctly here. So we have -2 squared. That is what we'll do first. So -2 times 4 plus -2, which is just -2 minus 1. So -8 minus 2 minus 1 is -11. So f of -2 is equal to 11. Okay, now we get into some more interesting territory. So in this case, we're going to take every instance of x and apply the value of -a. So this means I have my f of -a is equal to -2 times -a squared plus -a minus 1. Okay, so let's apply the square. -a times -a is a squared, so we have -2a squared minus a, that's plus -a, minus 1, and since all of these terms cannot be combined, this is my answer for f of -a. And I do this problem right next to the next one, which is -f of a, because you'll notice that I'm plugging the a in for every instance of f, but I'm taking the entire function and making it negative. So my f of -a is equal to the negative of the entire function where I've substituted a in for x. So this is -2 times a, quantity squared, plus a, again using parentheses to show my substitution, minus 1. So processing the inside of this parentheses first, a squared is just a squared This is negative 2a squared plus a minus 1. Now this, again, this whole thing cannot be simplified anymore because I can't combine like terms because they're different. But I have a negative here. And this negative distributes to all three of these terms. And so that makes this a positive 2a squared, showing this little line there for the distribution. This makes this a negative a, and this makes this a positive 1. So my negative f of a, shoot, I got all the way down here, and I made a mistake here. This is negative f of a. I know that's probably been bothering some of you since you saw me do that. But there it is. Negative f of a is equal to negative or positive 2a squared minus a plus 1. Now g and h are going to be some major work here. So let's do g on the bottom half. And you're going to want to write pretty small to get these last two in here. So, okay, let me start off with g. Okay, so we have the f of a plus h. So we're going to put this binomial, a plus h, in for every instance of x in the original equation. So this is going to give me negative 2 a plus h, quantity squared, plus a plus h minus 1. Okay, so starting this off with negative 2. One of the common mistakes is people write a squared plus h squared, but that's actually not right. This is a plus h quantity squared, so this is a plus h times a plus h. So this brings out our four-letter F word in math called FOIL. And outside we can just drop the parentheses because a plus h minus 1 is really just that. So I did go a little out of order with my order of operations, but I didn't really have anything to do here. But I will FOIL this. So this makes a times a, which is a squared. The f, the o, this is ah. The I, which is another ah, and I stack them up so we can combine like terms. And this is plus h squared. So this means I have negative 2 times a squared plus 2ah, because we have 1 in one of those, plus h squared plus a plus h minus 1. Okay, so we distribute the negative 2 to each of these, so we have negative 2a squared minus 4ah minus 2h squared plus a plus h minus 1. And this is my f of a plus h. There we go. That gives me what I need there. And now let's clear this off to do a very long part H, and that will finish the video. What we have for our function is we want to have the function of x plus h. So we're going to plug in our x plus h in for every value of x. And then we're going to subtract f of x. So that's just the equation as written. And divide by h. And we're going to assume that h is not equal to 0. Because we can't divide by 0. Big problem with that. So let's start off with our f of x plus h. And we'll give that the color green. So that is going to be negative 2. And then we have x plus h quantity squared plus x plus h minus 1. And we're then going to subtract our f of x, which I'll color blue. And that is going to be negative 2 x squared plus x minus 1. And this whole thing will then be divided by h. Now the first thing I'd like to do is I'd like to maybe distribute this negative. If I distribute that negative, maybe some nice things will happen. So, if I do that, what I then get is a positive 2x squared, and then I get a negative x, and then I get a positive 1. So let's look over here for a moment. I have x plus h minus 1. X plus h minus 1. Okay, well, what's kind of nice about that is that the plus 1 and the minus 1 simplify to 0. And this positive x and this negative x simplifies to 0. So here's what we have left. In green, I got negative 2 x plus h quantity squared. And again, the x and the negative 1, or minus 1, simplified to 0, so now I just have plus h, which is nice. Now over here, I have this minus 2x squared. And that's all I have there. And this whole thing is still divided by h. Okay. For those of you who want to cancel out these two terms, I have a more elegant way to do this, and also this would, if I just canceled these out, I would also have a division of h over here and a division of h over here. I'd have to break this into 3 fractions and do this simplification. I'm not going to do it that way. What I am going to do is kind of recall back to this previous answer here, where we did this work of this x plus h quantity squared, and I just want to show that work out one more time here. So I'm going to have negative 2 times the quantity of x squared plus 2xh plus h squared plus h, and then we'll have at the end here, now I'm going to start to, instead of busting out the red pen, I'm just going to start to blend this in with the black. So there we go. So I'm going to distribute this negative 2, and in doing so I'll just switch all of it to black, so I'm just going to continue writing this up here. So what we have is negative 2x squared minus 4xh minus 2h squared plus h, and then what we have here is a plus. Oh, that should be a plus. Sorry about that. A negative and negative make positive. So we have a plus 2x squared. I know that was probably also bothering you, like, oh, this is positive. It's not negative. It's positive. Okay. All divided by h. H. So do you notice anything cool here? Yeah, I'll get my red pen out and go blam. Blam. There is two x squared terms, both being opposite, which makes 0. So what this means, I have, going back to my black pen, this negative 4xh minus 2h squared plus h, all divided by h. Now what we can do here, you see that numerator now? That numerator has an h in every single term. This trinomial in the numerator each has an h in it, so what I'm going to do is I'm going to factor out an h. Factor out a little h here, which means that my first term now is just negative 4x. My next term is now here negative 2h, and my last term here is plus 1, because if I factor out an h divided by h is 1. All divided by h. See anything cool there? The h's simplify or divide into 1. So this means that this simplifies to negative 4x minus 2h plus 1. Now some of you with a little bit of experience in pre-calc and beyond might feel this problem is really derivative. Haha, get it? Derivative? Because this is the derivative formula, and what we would need to do to complete a calculus level derivative is to take h to 0, and that would leave us with negative 4x plus 1, which is the derivative of our actual formula, 2x squared minus x plus 1. And of course we can kind of go through and talk about that when we finally get to that level of calculus there. But at this moment, we are going to be fine with where we are right now with our problem and how we deal with, just how we deal with simplifying and plugging things into functions. And this will probably give you the level that you need to finish the homework for this section. And I appreciate you watching and getting through all the algebra. And thanks again.